Today's lesson is about extending the pattern, standard MA 6-8.6, demonstrating and applying a knowledge and a sense of numbers, including numeration and operations, which are addition, subtraction, multiplication, and division patterns, ratios, and proportions. So that's a lot of information that we're going to cover in one lecture, but hopefully I've broken it down so that you can see everything is related. The patterns will be exhibited in tables and in rules or words. We're also going to write things as expressions, and we're going to look beyond the pattern that we're given to explore a little more. So when you look at your notebook, you should have that patterns page taped up like the accordion towards the middle of your page, and we're going to get going with our notes. At the very top, underneath your learning goal, I want to write a quick definition of the word variable or the term variable. We've discussed variables throughout our learning already this year, but we haven't quite identified it as being defined at all. And so it's important for us to have a really good understanding. So a variable is a quantity that varies or changes. And it changes, and it's often represented by a letter. It can also be represented by a symbol, but in algebra, we are definitely going to see more letters than we are symbols. And it's important to know an example. N times 2 equals 6 is an expression in which n is the variable. So this particular example is called an expression. Where n is our variable. And expressions are just mathematical problems that include variables. So it's really straightforward in terms of looking at an equation or an expression. An equation has no variables. An expression has a variable because it hasn't yet been expressed in full number form because we're not sure what the value of the variable will be. So let's look at a pattern and see if we can figure out the expression or the table that we'll need in order to represent that pattern. I'm going to make myself a little table. There we go. And the first number in my table will be the term, and the second number will be the value. This is some terminology that we used in our most recent video. So just be sure to take a look and review what those concepts really do mean, right? What is a term and what is a value? So if I say the first number in my series is 2, and the second number is 6. And then I have another term that's 3 with a pair of 9, a term that's 5 with a pair of 15. This is a table that represents my pattern, right? Given the number 2, I find the number 6. Given the number 3, I find the number 9. these patterns have to be consistent, just like the patterns we were talking about when we discussed the Alice in Wonderland problems, right? So to get from the 2 to the 6, I have to do something that is the same as when I get from the 3 to the 9. In order to make sure that that's the same thing consistently, I need to identify the rule, and I need to be able to write it in words. So the rule for this particular problem, in order for me to get from the 2 to the 6, I can multiply by 3. This will also work to get me from the 3 to the 9 or from the 5 to the 15. So I'm going to identify my rule as multiplying the term times 3 to equal the value. If I want to write this specifically in an expression, I need to use variables. So I need to identify a letter, let's call it n, to equal the term number, and v to equal the value. My expression will look like n times 3 equals v. Another way to write multiplication of a number and a variable is to put the number in front of the variable and leave out the multiplication sign. For example, 3 n's will also equal v. Either of those equations will work in order to write my rule as an expression. Lastly, we're going to extend the pattern that we have. So in the table above, we have this information that was given to us, and we're going to see if we can build on that information. For example, if a number in the pattern was 9, how would I be able to find the value of the second number just by giving myself the term number? Well, in this case, I can multiply by 3. 9 times 3 is 27. So now I have my term number and my value. I can use another number, let's say 11. Using 11 as my term, multiplying it by 3 will give me my value, which is 33. So as you can see, having a rule for an equation or an expression will allow us to continue to be able to find missing pieces of the pattern, no matter what they are. It doesn't matter if my term number is 202, I can multiply it by 3 and I'll get the value in that position of the pattern. So when you're finished, your notes should look about similar to what mine look like. Your proof for tonight is to complete the pattern. I give you a pattern series here with a term number and a term value. So please go ahead and complete that pattern, filling in the blanks for all of the question marks. Also, this particular video lends itself to a very unique and interesting reflection, so feel free to use your creativity and expand on your learning even further.